insert and delete. Okay, insert and delete. So insert, in case of insertion, we have to add at beginning and at end at any position. Similarly, for deletion, we have to study this double linked list is very important for your exam purpose. At from beginning, uh, from end, and from any specified position. So insert at beginning. Insert at beginning. So double linked list. What is the uh, node structure for double linked list? So node structure for double linked list is that no node, struct node. As in case of double linked list, there are two pointers. One pointer is previous pointer, and the another pointer is the next pointer. So first pointer is the previous pointer, and middle one is the data. Middle one is your data, and last one is the next. So there are three fields. Okay. Now, as this is the self-referencing data structure, so struct node next. Okay. If you have any doubts, please ask me. And similarly, struct node if, and this will be let int. This is the int data. So this is the struct node. So this is the node structure for DLL. If you are asked for 2 marks in MCQ or 1 marks in MCQ, first you have to write. Suppose you are asked to write down the node structure for DLL, then first you have to answer this is the node structure, and then you have to draw the structure. So how to draw this structure? We know that there are 3 fields. So first one is the previous field, middle one is the data field, that D, and so this is the previous field P, and this is the next pointer N. So this is the node structure for our double linked list. Okay, why this is called the two-way list? Because using this previous pointer, we can traverse in the backward direction, as well as using the next pointer we can traverse along the forward direction. Okay, that's why this list is called the two-way list. So DLL is termed as two-way list. Okay, now how to insert in your exam, final markout exam, or in your class test? Often these questions may arise that insert at beginning. So how to insert? Let us draw the one example. This is your first node. Okay, so this is your first node. So first node, let the data part is 1. Let the second node is the with data part is 2. Second node data part is 2, and the third node, let the data part is 3. Now this is the last node. Okay, now the first node's data part is 1, and the previous pointer, what will be the previous pointer of the first node? Am I audible? What will be the previous? What will be the previous part of the first node?
Null.
Yes, sir.
The previous part of the first node is made null. Okay, nothing to point. Similarly, the
Null,
next
sir.
part of the last
Null,
node,
sir.
next part of the last node is made null. Okay, now as this is the two-way list, so next part of first node pointing to the second node. Similarly, previous part of the second node is pointing to the next part of the first node. Okay. Similarly, we can draw this diagram also, this pointer also. Okay. Now this is the header or start node, first node. This is the header or start node. Okay. This is the node structure of double linked list. Now you have to insert. Suppose you are asked 5 marks, with 5 marks a question that insert a node, write a program or algorithm. Write a program or algorithm. Program means just the code fragment, that is just the function. Okay. Or algorithm. Write the algorithm for insert a new node at the beginning of the double linked list. So what should we do? First, we have to dynamically allocate. First, we have to dynamically allocate this new node. Okay, right? We have to dynamically allocate the new node. Then we have to insert the data. We have to insert the data. Let the data is 4. Okay. User input data 4. We have to user input data 4. Then what should we do? Any idea? What should we do? We have
Sir, the next part of 4 should be connected to the start node, and the previous part of 4 should be made null.
So previous part of the 4 is made null. Okay. And our next operation is delete this branch. Delete this branch. And as this is the two-way list, so made a connection from previous of 1 to 4, and at the same time made a connection from next part of 4 to the previous part of the 1, and finally cross this S and made S here. Okay, so this is your new start, new head. Okay, is it fine up to this? Any
Yes,
problem?
sir. No, sir.
Okay, so insert beginning.
Yes, sir. No, sir.
So insert beginning, just we are writing the code fragment or function. So insert beginning. So insert beginning. So there will be one argument. Let the argument is start, and the return type of the start is as this is the self references. So struct node, and the return type let struct node. Now we have to insert a new node. Okay, so new node. So you have to dynamically allocate the new node. Sorry, new. Let this is new. Okay, and start node. Now let the data part is int n. That is the value of n is 4. In our example, the value of n is 4. Now enter the data. Enter the data. Okay. So enter the data. So enter the data. What will be the data? So data will be n. Okay, that is 4 in our example. Next, you have to dynamically allocate the new node. So new node is equal to, first one is the cast type, struct node star, and then malloc and byte size. So size of and struct node. Then you have to dynamically the node is dynamically allocated, and you have to insert the value data n. So 4 is inserted at the data part of the new node. Up to this 4 is 4 is inserted. Okay, 4 is inserted, and the node is dynamically allocated, and 4 is inserted. Now, now let this is the first operation. Let this is the first operation, that is the previous part of the start. Initially this was the start. In previous part of the start, initially this was made null. So omit this null. So you have to omit this null and you have to make this connection. So previous part of the start is new node. Okay. So start previous is new node. So this is the first operation. What will be the next operation? Let this is your next operation. Let this is your next operation. What is the next? So next part of the new node, this is the new node NN. The next part of the new node is made start, previous part of the start. So start. So new node. If you have any problem, please ask me, please clarify. So new node next. So next part of the new node is made start. Okay. And there is another thing. This is the third operation. That is made the previous part of the new node to null. So new node. So new node if is equal to null. Anything else? Is it fine? Or?
Start equals to new node.
So start. So start is new node. Okay. And return start. So start is equal to new node. So this is our fourth operation. So first operation is made the previous connection of the start node to the new node. Second connection is next part of the new node is pointing to the first node, that is start node. Third connection is previous part of the next node is new node is made null, and fourth operation is that made the new node as the start node. Okay. So there are total 4 operations. These 4 lines are very important for inserting at the beginning. Okay. So this is the code for insertion at the beginning. Now your new node, now your list contains 4, 1, 2, 3. We are interested for insertion. We are interested for insertion at the end. Let the data is 5. So that the list looks like 4, 1, 2, 3, 5. So what should we do? So struct node, just copy and end at end. Sorry. So struct node insert at end. Okay. Insert at end. So these lines, these 4 lines should be omitted. We delete these 4 lines. Okay. Now for insertion at the end, we have to traverse the whole list up to the last node. Okay. So up to the last node. So while for scanning the entire list, that is the temporary pointer PTR. So PTR, the rule is PTR arrow next, not is equal to here, as this is the double linked list. So last part of the list is made null. So while PTR next not null, you have to advance. So advance is ptr is equal to ptr arrow next. Okay. Now we have to declare this ptr. So let the ptr is start ptr start node. Okay. Now we are at the after completion of this while loop, these two lines, we are at the last node. Okay. Now what should we do? So your pointer p now is at this position. So now what should we do? The next part of this p, the next part of this p should point to the new node, right? So this is our first operation. Okay. What will be the second operation? Any idea? What will be the second operation?
So previous of new node should point to the P.
So previous of new node. So this is the second operation. Previous of the new node is pointing to the P. Okay. And what will be the third operation? Third operation is next part. So this is the third operation. Next part of the new node is made null. Okay. So first operation is this, second operation is this, and third operation is this. So how to write the first operation? So first operation is that ptr arrow next. Okay. Ptr arrow next is, so ptr arrow next is new node. The second operation is, what is the second operation? The second operation is the previous part of the new node should point to the ptr. So new node. So new node, sorry, new node prev. New node prev is your ptr. Okay. And finally, the next part, uh, the next part of new node is made null. Okay. And return start. Okay. So this is the condition, this is the function for insertion at the end. Okay. Insertion at the end. So if you are asked to write the program or write the algorithm for insertion at the end in a double linked list, you have to draw this entire diagram, and step by step you have to explain this along with the either this code fragment or algorithm. Okay. Then you will get the full marks, 5 out of 5. Oh, so at any position.
Sir,
Yes.
so can you show the inserted beginning part once more? Like just the code.
Yes, this is the code.
Yes. Thank you.
Okay. So insert at beginning. Next. So this is the insertion, insert at beginning. So this is the insert at end. Now insert at any position. At any position that is before and after any node, before and after any node. Okay. So let this is before. This is before. So struct node, insert before. Insert before. So n, and at the same time this will be your value. So enter the data is inserted. Okay. And printf enter enter the node, enter the node before which we are interested for insertion. Okay, insertion. So this will be your val and if this is complete the C code. You can ignore this and you can modify in your own way. That is, you can also write the algorithm in your exam, but you have to explain the diagram step by step in every execution. Then only you can get the full marks. Okay, so %d and this will be your value. It is stored. Okay. Now new node is dynamically allocated. Up to this, any problem? New node is dynamically allocated and the data is inserted at the data part of the new node. Okay. Is it fine? So one thing is that new node is dynamically allocated. New node is dynamically allocated and data part of the new node is n. There should be online PTR, as PTR is traversing from the start up to the last, so PTR is equal to start. Okay, you should clarify this. কেউ কিন্তু আমায় বললে না এটা। শিরিন আছে এখানে? শিরিন, at least ওর বলার উচিত ছিল এটা। So PTR is equal to start. Is it fine? PTR is equal to start, so that we can traverse up to
Yes,
the
sir.
up to the last node.
Yes,
So
yes.
while PTR
Yes,
not
sir.
equal to null, so while PTR not is equal to null, so PTR is equal to advance. We advance the PTR. Okay. Now we delete these three lines. Now what will be the operations? So insert before. So insert before. Let the new list is 4 1 2 3 5. Now we are interested for insertion. We are interested for insertion 6 before 3, that is between 2 and 3. Before 3 we have to insert this newly created node 6. Okay, so what should be the appropriate actions? কি করব বলো তো?
Sir, first we will have to traverse till 3 and at
Okay, should we use the 2 pointers, pre PTR and PTR?
so here I think because we have connection with both, I think it will work without a pre-PTR.
So first connection, let 6 to next part of the 6 to
PTR.
the previous part of the PTR.
Yeah, previous
Okay,
part.
that is PTR. Okay, that is PTR. So new node next is PTR. New node next is
Yes,
PTR.
part of the PTR.
This is the first action.
And
Okay.
previous of new node should be the previous of PTR.
Previous of PTR. So this connection should be made. So these are the second operation. Okay. Next, as you are at this position, so next part of the PTR previous is pointing to the new node. So this is the 3. And the fourth connection, the previous part of the PTR is pointing to the new node. Up to this, any problem? This diagram? If you have any problem, please ask me. Is it fine? How to insert
Yes.
this 6
Yes,
between
sir,
2 and 3? between 2 and 3.
Yes, sir.
Yes, sir.
So first action is,
Yes, sir.
so if you write the first action, so what is the first action? First action is the next part of the new node. Next part of the new node is pointing to the P. Okay, so this is the first action. So first action, new node,
Sir,
next.
sir,
Yes.
sir, I think the traversing part should be different, no?
Yes, sir,
Next.
null করলে তো লাস্ট অবধি চলে যাবে, পুরোটা ট্রাভার্স করে নেবে।
While PTR is not equals to
Yes,
the
yes, yes. Very
value
good, very good,
printed.
very good. Yes, yes, yes. So PTR next not is equal to val, right?
While PTR is not equals to val, PTR next will
Sorry. PTR next not PTR data.
yeah.
PTR data not is equal to val. Okay. While PTR এখানে তো নালই হবে, হ্যাঁ এটা তো নাল হচ্ছে। PTR data not is equal to val, very good, and advance. Okay. So now this is the first one. So this is the first action. Okay, first action. What will be the next action? So this is the first action. Okay, what will be the next action? Previous part of the,
New
is
node.
it visible? Previous part of the next, previous part of the new node is pointing to the PTR previous, right?
Yes, sir.
So new node prev is PTR or PTR prev. So this is the second action. Okay, what will be the third option? The third one is that PTR pre-PTR next, that is PTR previous next, is pointing to the new node. Okay, so PTR previous PTR previous next, PTR previous next is equal to new node. So this is your third operation. Up to this, any problem?
No, sir.
Then fourth option, fourth action. What is the fourth action? Fourth action is that previous part of the PTR. So previous part, so PTR previous is equal to new node. So this is the fourth part. Okay, so this is the fourth part, and return start. So this is the code fragment for insert any node before insert a value before a given node. Okay, then after is your homework. Can you do that? After করতে হবে না করতে পারবে? After তনুশ্রী কি বলছে? Can you show the previous code? My net connection is bad.
স্যার আমি ওই যেটা জিজ্ঞেস করলাম ওটাইও বলছিল তো আমি
আচ্ছা ওকে থ্যাংক ইউ। আচ্ছা এই কোডটা পারবে না করে দিতে হবে?
স্যার আই থিংক
করে দেবো?
পারবো
স্যার
স্যার।
একটু দেখিয়ে দিন।
আচ্ছা দেখিয়ে দিন।
স্যার একটু দেখিয়ে দিন।
Okay, so after, so the new node, sorry, the list is now 4 1 2. So the list is now 4 1 4 1, next 2 6 4 1 2 6 3 and 5. Okay, This is your list, double linked list. Now you have to insert uh, after 3. You have to insert after 3. Let the data is, let this is 7. Let this is 7. Okay. So after sorry, এটা কি হলো বলো তো? আমি ডিলিট করতে ইরেজারটা ইউজ করতে পারছি না কেন?
স্যার ইরেজারের ওটা
স্যার
কালারটা
কালার
ব্ল্যাক
টুটা
হয়ে
হোয়াইট
গেছে।
করুন, কালার টুটা
কালারটা
হোয়াইট
white।
করে দিন।
কালার টুটা হোয়াইট করব?
হ্যাঁ
কিভাবে করব? আচ্ছা, কালার টুটা হোয়াইট। আচ্ছা,
হ্যাঁ।
ওকে, থ্যাংক ইউ।
স্যার
হ্যাঁ,
4123 412635, তো
Okay,
আমি 3
thank you.
এর পরে কেন করব? 5 এর বিফোরেও তো করে দিতে পারি, জিনিসটা তো একই হবে।
একই, সেম।
আফটারটা তাহলে আমাকে কেন আলাদা করে করতে হবে?
আমি জাস্ট ভ্যারাইটিস গুলো শো করছি, আর কিছুই না।
ওকে ওকে ওকে, থ্যাংক ইউ।
ওকে, আমি জাস্ট ভ্যারাইটিস গুলো শো করছি, প্রিপিটিআর অর কানেকশন, হাউ টু মেক দ্য কানেকশনস। তুমি 3 আর 5 এর মধ্যে 5 এর বিফোরেও করতে পারো। You have to insert between two nodes. That's why the code is insert at any specified position, either before or after. Okay. So 4 1 2 6 3 5. Now you have to insert after 3. So in between 3 and 5. That is before 5. Okay. So here after after. So we have to copy this one. After. So insert after. Okay. So up to this, the new node is created. In value, enter the data, enter the node before which you are interested. Value node is created dynamically, and this is the data n is inserted at the data part of the new node and ptr. Okay, so up to this, no problem. Now ptr data not is equal to value, you have to proceed. ptr data not is equal to value, while ptr data not is equal to value, proceed. Okay, so up to this, you are at uh, at data, add data value, after add data value 3. এই পার্টিকুলার এক্সাম্পলটার জন্য বলছি। ওকে, নো কানেকশনস, এর সাথে কিন্তু চেঞ্জ করলে কিন্তু কোনো কানেকশনও থাকছে না। আফটার কমপ্লিশন অফ দিস while loop, you are at the data value 3. Now what will be the appropriate connections? Any idea what will be the appropriate connections?
Yes, sir.
Yes, sir. New node next should be made ptr next.
Yes, very good. So new node next, color 1. So new node next is made with the ptr next. Okay, you can use 2 pointers, pre-ptr and ptr. Then you have to write this is pp pre-ptr, and this will be your ptr. After every iteration of your while loop, you have to copy the ptr to the pre-ptr. Okay, and then you have to advance the ptr. And if you are using the single pointer ptr, temporary single pointer ptr, then this node is your ptr next. Okay, right?
Yes, sir.
So new node next, is PTR next. Let this is your first operation. Okay. So what will be the next operation?
PTR next previous should
PTR next previous.
is
So PTR next previous is now pointing to the
new node.
new node. This is your second operation. Okay. What will be the third one?
So PTR next should be new node.
PTR next should be new node 3.
And new node previous should be PTR.
Simple. Simple connections. There are total 4 operations. So number 1. So it is the number 1. This is after. So before which, after which. This will be after which. Okay. Now number 1. What is the number 1? Number 1 is that কি বলেছিল number 1টা? Number 1 হচ্ছে new node next
New
is
node
PTR
next.
next. Is PTR next. Okay.
PTR next.
So new node next is PTR next. Okay. So this is the first. What will be the second? Second is that previous part of the PTR next. So previous part. So PTR. So PTR next. PTR next. PTR next. Its previous part. Okay. Its previous part. This will be equals to your কি হবে?
New node.
New node. Okay, second operation. What is the third
New
operation?
node.
Third operation is that PTR next. PTR next is the new node. So third operation is that PTR আমি ঠিক করছি কিনা একটু খেয়াল রাখবে, ঠিক আছে? PTR next. PTR next is the third. PTR next is equal to new node. And fourth condition, what will be the fourth condition? So the fourth condition is that new node. What is the fourth condition? Previous part of
New
the
node
previous part of the new node is pointing to the PTR. So new node previous. So new node previous is equal to PTR. Is it fine? These 4 lines.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
So these are the functions or algorithm or code fragment for insertion after a given node. Okay. So up to this, insert at beginning, insert at end, at any position that is before and after. Clear? Or you have any queries, please ask me.
No, sir, clear.
No, sir, clear.
So the new list now looks 4 1 2 6 3. 3 next is 7. Okay. 7 5. Now you have to delete the first. You have to delete the first node. How to delete from beginning? Any idea? So delete. Let beginning.
Sir, start next previous should be made null.
One second. Start previous.
Start next previous.
Start next previous. Okay. Start next previous is made null. Then
And start equals to start next.
yes.
And then this
Free
earlier
PTR.
one should be stored in some PTR and free PTR.
Okay. So delete start node star delete beginning start node start. So you have to delete the first. You have to delete the first node. Okay. So we have to use the temporary pointer so that we can copy the start, the main start, initial start to the temporary. So struct node ptr. This is the temporary. Next, our next task is to copy the start, the ptr. So 4 1 2 6 3 7 5. So 4 is the start. So ptr, this is the ptr. So you have to copy this s. So you have to copy this s in the ptr. Okay. So this is your ptr, right? Temporary pointer. You have to copy this. So copy the ptr is equal to start. Okay. Then you have to advance the start. So start arrow next. You have to advance the start. And so now what will be the start? So your start now pointing at the second node 1, that is at 1, right? Now the previous part of the one is made null. Okay, so this will be crossed. So start what will be the code?
Start previous equals to null.
Start previous is equal to null. Okay. Okay. And now you have to see the ptr. Okay. Free ptr. Return start. Is it fine? So delete the first node. If you have any queries, please ask me. So
Also clear.
delete the first node. So first node is deleted. Now your list now becomes 1 2 6 3 7 5. Now you are asked to delete. You are asked to delete the last node 5. How to delete the last node? So we just copy from the beginning, and you have to delete. আমাকে এগুলো delete বসে বসে করতে হবে. So from end. So from end. How to delete from end?
Sir, first we will traverse to ptr next equals to null. First we
Okay,
will-
so we have to traverse up to the last one. So the
Yes.
condition is that while your ptr arrow next
Yes, sir.
not equal to null.
not equals to, very good, not is equal to null, and we have to traverse ptr is equal to ptr arrow next. Okay, after completion of this while loop you are at the last one.
Yes.
Okay, so delete these two lines. Oh, again these lines. Okay, now you are at the last one, so you are at this position 5. So you are at this position 5.
Yes.
Now what should we do? We have
Sir.
to delete this. We have to delete the last node. This 5 should be deleted. Okay, so this 7 that is previous of this ptr, that is ptr, the next part of this 7 is made null.
Null.
Okay,
And then free ptr.
if you have any queries, please clarify. the next part of this 7 should be made null because your 7 is now the last node. Okay. So what will be the condition? What will be the condition?
PTR
So
previous next.
after completion of the while loop, you are now at the last node. So PTR previous. Okay, PTR previous. That is 7. Node number 7. Node with data 7. PTR previous. That is pre-PTR. So the next part. Next part of the PTR previous is made
Null.
null. Made null. Okay. And what will be the next one?
3 PTR.
E
Null.
or null cano. PTR. PTR. Okay. Up to this, any problem?
Sir, I have a question in the deletion at the beginning.
Deletion at the beginning.
Yeah,
Suraj.
sir. What was the use? Yes, sir. Yes, sir.
Yes.
Actually, my net connection is not too good, sir.
Okay.
Okay, okay. Sir, I was just asking that what is the use of PTR in this code?
PTR is the temporary. PTR is the temporary. This is actually the temporary pointer that stores the first node. Okay.
Sir, but we don't need the first element in the further code, right? Because we have not used any more PTR in the
So
code.
you are just ignoring the PTR and you
Yeah.
are advancing the start. That is start is equal to start next. That is start is equal to start next, and then start previous is null, and then print the whole list. Okay. এটাই বলছে তো?
Yeah. Yes, sir.
আমরা কেন PTR ইউজ করি anyone?
Sir, PTR is just used so that we can keep track of that node and
No,
then
no, no.
later free that
No.
part. Free
PTR is used for traversing or scanning the whole list. Okay, but here why we use the PTR? Because when you are deleting a node, that is according to Suraj ki chaiche, Suraj is interested for break the chain. You are interested for break the chain. That is if S is pointing to the 4, as per Suraj, 4 S should be at 1. Okay, then he will print 1 2 6 3 7 5. But what about the deleted node? Sorry, what about the first node 4? When there is no use for the node, you have to use, that is you have to free the space. That's why this is the physical meaning for deletion. You have to delete the first node. You have to give back that node, give back that free space to the avail. That's why for beginning, at the deletion of the node at the beginning, your PTR is used. The PTR is used in two sense: for traversing the whole array, starting from the head or start. This is one thing. And the second thing is that deletion at the beginning. While deletion at the beginning, you have to put the start or head at the temporary pointer. Okay, and then advance the pointer to the next node, and finally free the temporary pointer. Then only your deletion is complete. Are you getting this, Suraj?
Yeah, sir, I'm getting that. But I have a different question. For example, we are storing start in PTR, okay?
Yes.
After 2 lines of code, we are again freeing that PTR. Then what is the need of that? After 2 lines of code, we are freeing that PTR, which we took as a temporary pointer.
Then how to delete?
I understood that. Initially, I understood that initially we are storing start into the PTR, but just after 2 lines of code in which we don't use PTR,
PTR
then why do we need
PTR,
it?
PTR is used for this is the particular scenario where PTR is used only for storing the fast. Here the PTR, here only the PTR is used for storing the fast node. And what about the deletion? Deletion means you have to free the space, allocated space along with the data. Then only you can delete. Okay.
Okay, sir. Okay. And what if we just
Unless and until you use the free function, unless and until you use the free function, the space is not deleted.
yeah. Sir,
Okay.
I was asking that what at the time of initializing the start as start equals to start next. At the same time, if we free the free the start node, then what happens?
কেউ বলতে পারবে সুরজ যে কোশ্চেনটা করলো?
At the same time, we will free that previous
Sir.
part and we will start initialize start as start next.
Sir,
সুরজের
I can-
কোশ্চেনটা কে পারবে?
Sir, if we actually free the start at the same time, then we can't do the function as start equals to start next. It will just throw an error.
Yes.
There is no existing node at that time.
Yes, Suraj, first do the full program, okay? Then delete
Yes,
the
sir.
first node without using the PTR. Or PTR is equal to start, next line free PTR. Then just investigate the answer and inform me.
Okay, sir. Thank you, sir.
Okay.
Okay.
Up to this, any problem from beginning, from end? We're running late. From beginning, from end? Any problem?
No, sir, no problem.
No, sir, no problem.
আচ্ছা নেক্সট ক্লাস তো স্টার্ট হয়ে যাবে এটা পারবে তো নিজেরা ফ্রম এনি পজিশন ডিলিট ফ্রম এনি পজিশন
Yes, sir, চেষ্টা করব না
Okay,
হলে
so-
আপনাকে জিজ্ঞেস করে নেব।
ওকে সো দিস ইজ ইয়োর হোমওয়ার্ক ওকে থ্যাংক ইউ ইফ ইউ হ্যাভ এনি কোয়ারিজ প্লিজ আস্ক মি
Sure, sir.